For this next video, I'm just going to go through a lot of examples of different ways that we can utilize the 10 Commandments of Logarithms. I have them written out here. These 10 Commandments, things we saw in a previous video, are very useful for simplifying and expanding and solving logarithms and evaluating them. And so we're going to utilize those, and I'll just show you some tricks and some things that you'll see common to the problems in my math lab homework and what you'll be tested on eventually. So anyway, I have a whole list of problems here. We'll work through them one by one. First thing is finding the domain of a logarithm. This really comes down to the idea, property number 6, that the logarithm is undefined if you plug in a negative or a 0. And so essentially the domain is all positive numbers. So the stuff that goes into the log here has to be positive, which means the x value has to be any numbers that make the whole argument positive. So what we're going to do is we're going to take the argument, set it greater than 0, because it has to be positive. It cannot be negative or 0. And then we're going to solve that. So you subtract your 3, you get 2x is greater than negative 3, and of course when you divide out the 2, you get x is greater than negative 3/2. And so our domain then would run from, let's see, it's greater than, so it's going to start at negative 3/2 and run to infinity. Okay, there's your domain. Now some of the domains you're going to see might have a more complicated function on the inside. This was a simple linear function, but you may end up with, say, a polynomial or a rational function and have to solve a polynomial or rational inequality, which is just like what we did in section 5.4, okay, using a sign chart. Alright, number 2, we're solving an equation, and this equation is not obvious because it involves a logarithm and the variable is down in the base. But if we utilize the first property, the first commandment, and just convert the logarithm to an exponential, that can help us. So I'm going to convert that by saying the base raised to this third power is equal to the argument. Base to the third power equals the argument. Okay, because we know that the answer to a logarithm is always the power on the base that gives you the argument. And so from here I look at this equation and I think, well, I can't really solve. I guess I could solve by using cube root. That would work, right? I could take the cube root of 1/8. So x equals the cube root of 1/8, because a cube root undoes the cube, and a cube root of 1/8 would be equal to 1/2. So 1/2 is our solution, and of course we should put a solution to an equation should always go in solution set form. And so there's my solution set. Now if I wanted to evaluate a logarithm, I've got a bunch here evaluating things. What's that? 3 evaluations, and they're all based upon these properties of logs. So this first one, you have natural log of e to the 14. Well, remember the natural log itself has a base of e. It's like, oh, I'm sorry, it's like taking log base e of e to the 14. Right? The natural log is log base e. And so if you look at our property list, this does match up because the base on the log and the base in the argument are the same, just like they are here on property 4. And so the answer then is just the exponent. And so here 14 is the exponent, so according to property 4 the answer is 14. Okay. Alright, maybe I'll keep the property list on here as I go. Let's see, if I want to evaluate 2 to the log base 2 of 13. This has a logarithm inside of an exponential. We've seen that in one of our properties right here, a logarithm inside an exponential, property 5. As long as the exponential and the log have the same base, which they do in this case, they're both 2, then the answer is simply the argument. And so here the answer is just simply 13. Alright, property number 5, example number 5. This one's a little bit tricky because we have a logarithm in an exponent, which is similar to the previous example, but here we have actually 2 logarithms. And it'd be nice to get them down to 1 so that I could apply property 5. In order to get 2 logarithms into 1, I'm going to use property 7 first. It has a sum. I'm going to go backwards and convert it into a product, the logarithm of a product. And so this will become 5 raised to the log base 5 of 8 times 4. Right, so the sum on the outside becomes a product on the inside. And then I'm going to just evaluate that, 5 raised to the log base 5 of 32. And of course, according to property number 5 now, as long as the bases are the same, the argument of the logarithm is the answer to the log, or to the expression. Okay. I can jump down here, maybe I can estimate log base 2 of 7. Now log base 2 of 7 is not an easy value to find because there's no easy power of 2 that gives you 7. It's going to be just under 3 because 2 to the third gives me 8, and 7 is just under 8. So what I'm going to do is I'm going to actually use the change of base formula, this guy down here, and I'm going to change this to another base, and I'm going to use base, I could use common log or natural log. Maybe I'll use the natural log since I've already done an example of common log on a previous video. So I could change this to the natural log of 7 divided by the natural log of 2. Go to my calculator. Oops, get rid of that. I can go natural log, where is it? Natural log of 7 divided by natural log of 2. And I'm going to have approximately 2.807. Alright, so this is approximately 2.807, which is reasonable. It should be just under 3, like I said. Okay, just a couple more problems here. This one I'm going to do an expansion. I'm going to take a logarithm that has a bit of a complicated argument and expand it so that it's simpler. Notice that we can take a ratio in an argument and write it as a difference of 2 logs. So I take the log of the top minus the log of the bottom. And this bottom log, log base 3 of 9, can be evaluated because there's an easy power of 3 that gives me 9, and it's 2. So this actually equals log base 3 of x minus 2. Okay. Alright, last one. Oh, actually, no, I've got a couple more. Expand this one. This one has a product with some powers on it. And so I'm going to use my product to a sum, property 7, and expand this out. This becomes log